So guys, we have completed the data cleaning part. Now let's go and perform some EDA. Okay. So now we are going to probably start the EDA and EDA full form everybody knows, that is exploratory data analysis, right? So here is what we are going to basically start. So right now my df_copy.head, and please make sure that you keep a CSV file ready also, so that if probably this particular data gets messed up, we can probably read that particular data from the CSV file. So over here you'll be able to see I have all these features. Now one by one we'll try to understand with respect to this particular features. We'll try to divide this into categorical and into numerical features and many more things. Okay, so first of all, in the EDA, as usual, let's go and check df of app. Okay, and what I'm actually going to do is that first of all, with respect to app, one thing that I'm going to see is that whether it is duplicated or not. So is duplicated, we'll try to see. So let's see whether this will work or not. It will give us an error because there are so many records. Series object has no attribute, is duplicated, no worries. So what I'm actually going to do over here is that I will write df dot duplicated of app. Okay, so if I probably try to see this and see the output over here, I'll be either getting false or true. So if I really want to find out how many records are duplicated, so I will probably go ahead and write df of this one, because see, app, if there are duplicates, those data points, like if there are duplicates data points with respect to that, then I think we will almost be getting the same information in the entire data set itself, right? So if I write like this and if I probably see this, so these are probably the duplicate app names that are available, right? And if I go and see the shape, and this shape will basically be 1181 records. The total number of records are 10,000 and 1181 are basically duplicate records. So from here, the conclusion that we can make is that, I'll not say conclusion again, I keep on saying conclusion, you should say about observation, that the data set has duplicate records, right? So here I have all my duplicate records. So I will go ahead and make this as a markdown so that this observation I can definitely see. Now what I'm actually going to do, obviously drop all the duplicates. So in order to drop it, I will write df dot drop duplicates, and here I have to give my subset parameter, which will be basically my feature name. Okay, and I will just make sure that I'll write another parameter which is like keep is equal to first. Okay, now this keep is equal to first basically means the first record will be kept, and if there is a duplicate record similarly, it will get dropped off, right? And after this, what I can actually do over here is that, and okay, let's see for df_copy. Okay, I have to probably check it for df_copy. Yeah, same thing here also. I have to make sure that df_copy, and let me just save this in df_copy. I can do like this, or I can also use a parameter like in place is equal to true. So fine, I've got executed. Now if I go ahead and see df_copy.shape, I will be able to see that many number of records is removed, and now we have 9,651 records, right? Now let's go ahead and probably explore data more. Okay, since we are doing the EDA and we know all the steps, probably so many examples we have done, right? Now first thing with respect to exploring data, obviously, is to find out how many numerical columns you have and how many categorical columns you have, and we know how to do that. So I will just directly copy and paste it for you, and like this. So feature for feature in df_copy.columns_copy.columns, and I will say if df for feature.data type is not equal to object, is equal to object. If it is equal to object, that becomes categorical features. If it is not equal to object, then it becomes numerical feature. Again, we have discussed a lot of many times, so I am not going to again discuss about this. So I'm getting an error which is basically saying day. So in which line? df of feature. Okay, so for feature in df.columns, if df_copy. So that is the problem. I had written df because I had copied it, but we have created another variable. Now I think we have 9 numerical features: rating, review, size, installs, price, last updated, day, month, year, and we have 7 categorical features like app, category, type, this, that, right? So all this information is basically there. I'm also going to give all the information of the feature that you have over here, okay, so that you can keep this for your own for your own, let's say you want to know about, more importantly, you want to know about this features, you can refer this entire features, basically what this features basically say. Okay, just to give you a good idea about all the features that we are going to use. So 9, 10, okay, I'm just using some numbering. Okay, 11, oh sorry, I have to use this as 11. This will be 12, and finally I have this 13. Okay, done. So I'll make this as a markdown, and probably we are going to keep this feature's name. This is basically giving you the entire feature information. Now with respect to categorical features, now since there are like 7 categorical feature, I'm just going to do one thing. I'm going to basically find out what is the proportion of count data on categorical columns for every different kind of features itself, every different kind of categories itself, right? So for categorical columns. Okay, so for this I will say for column in categorical features, and here I'm going to basically print df of column dot value counts value underscore counts, and this value underscore counts will basically give you how many each category is, how much values is there. Now if there is also one feature which is called as normalize. If I probably set up this feature as normalize is equal to true, instead of giving in the form of numbers, it will give us in the form of percentage. Okay, so this entire value I will just try to multiply by 100, so that you will be able to see that entire thing in the form of numbers, right? And finally I will just print like this, so that I give it in a better way, and you will be able to see this. Okay, now see the advantages. When we do normalize is equal to true, and when we are multiplying by 100, this is what we are basically getting. So Roblox, that you can probably see over here, is basically this much. CBS is this much. ESPN is basically 0.06%. So it is nothing but 6% in short. Meet You, family, this all the information is basically available, right? So this is with respect to all the proportion that we are able to see. Okay, and over here you will be able to get an idea like how it looks like and what are the features, what are the categories with respect to this. Okay, so this was one thing that you can specifically do with the categorical data. Now the next thing that I am probably doing is that we can compare different categorical columns also. Okay, so let's do one more thing. I'll write a comment. In visualization diagram, we will try to see the proportion of count on categorical column. So let me just quickly copy and paste one code. Now I think you will be able to understand. This is the figure size 15,15 univariate analysis of numerical feature. Okay, so for I in range with respect to this numerical feature, every numerical feature, okay, sorry, this should be numerical columns, not categorical columns. So that was my mistake. So now if you probably see this, I've used KDE plot to probably take all the features and compare that. So with respect to the KDE plot, the X variable, but one of the numeric and data time is required. So I have to use df underscore copy somewhere. Let's see. So this will be df underscore copy. Perfect. Now if you probably execute this, so this is how a univariate analysis of the numerical features are there. We are using KDE plot. KDE plot basically means kernel density estimator plot, and this is how your entire plots look like. Okay, now from this, what kind of observation you can make through, right? So if I probably consider rating with density, right, over here you can see that this is left skewed data. If I probably see rating with let's say rating and year, where is rating and year? Year is over here, and rating day, month, year, install, price, last update, rating, reviews, and size. Okay, so if I probably see with respect to rating, this is left skewed. With respect to year, this is also left skewed. Okay, and some of the data is looking like this. Last updated is also basically left skewed. So this is the observation I can definitely make out of it, right? So observation I'm going to basically make over here as rating and year is left skewed. Okay, left skewed. I'm just writing my observation, whatever is basically coming, while reviews, size, installs, installs and price are right skewed. Let's see whether this is true or not. Price reviews, this is also right skewed, perfect. Right skewed, yeah, perfect. So this will like price is also kind of right skewed itself, right? So all those information we are able to see that yeah, some of the data points with respect to the price, this is obviously right skewed, installs is right skewed, and reviews is also right skewed. So this is the observation that we can probably make out of it. And here I'll just make it as a markdown. Since there is right skewed, obviously we can also come to a conclusion that outliers are definitely present. Okay. Now similarly, we can basically do it for categorical features. So let me just go ahead and probably write it down over here. So again, same figure size, category I've taken type and content writing, length of category I've used plot, and whenever we have a categories we have to use count plot, and I've set some palette size. Okay, X label is this, Y label is this with 45 degree. Now if I execute this, so here you will be able to see that this one left one is there with respect to free, what is the count, with respect to paid, what is the count, and over here you can see everyone teen, every 10 plus, 10 plus, everyone 10 plus, mature 10 plus. With respect to different content rating, we are also able to see the count. So quickly we can also make the quick observation, that is what we are actually looking for, right? And over here what we have done, we have used count plot, right? Count plot with respect to category, and the next one that we are probably plotting is with respect to this values, right? So here again, this particular diagram, now you can probably make the conclusion out of it. Just see to this, just with respect to the data, you can see free is basically having a huge count, and over here with respect to different categories on content rating, you'll be able to see over here, right? So type and content rating, that is what we are looking at. Okay, now let's answer the main question. Which is the most popular category? Okay, popular app category. Okay, so this is my first question. Okay, and for this we will try to use a pie plot. Okay, which is the most popular app category. So if I probably write df of copy dot head of 2, so obviously most popular category, so this category we have to actually look at, and in order to do this, there are different categories. I'll just go and see how much percentage it is, and then we'll be able to find it out. Okay, so here I will write df of df underscore copy of category dot value underscore counts dot plot dot pie. Okay, so here I'm going to basically use the pie chart, and here I'm going to basically write df of category. See this, by using this pie chart, I think we have not used pie chart anywhere in the EDA, but I really wanted to show over here. So this will basically be my fixed size, and here I'm going to mention my fixed size as 15,6. Okay, so let's go ahead and execute this. Plot assessor takes one positional argument, but two are given. No worries. Let's see this. What is the problem over here? So this basically will be my Y value, and this will basically be my fixed size. Okay, now it should work. Now here you can basically see, yeah, so many different categories are there, so many different values are there, and the type of fixed size that I've actually used is 15,6. Let me make it to 15,16. Then you can actually see this very clearly, right? So most popular app category, obviously family is there. If you want values over here, I can also use another parameter which is called as auto PCT, that is percentage, and this will be percentile 1.1 F. Okay, so once we set up this value, you'll be able to see this. So this is like all the features that you can use in visualization. So family is basically having 19%. Then you have game 9.9, tools 8.6. So definitely the observation that you can basically make, the insights that you can basically make. Let me go ahead and write the observation just by seeing this pie plot. Okay, observation, insights, they are, so first observation to this is that, and this is basically my second observation. Okay, I have already seen this data set and done it, so I'm writing that observation directly. There are more kinds of app in Play Store which are under categories of family, games and tools. So family, games and tools, maximum percentage are there. Beauty, cosmic arts and weather kinds of art are very less in the Play Store. Okay, and this can also help you to decide your next startup. Okay, you can probably use this. Now let's go ahead and go and see the top 10 app categories. Okay, if I really want to see this, and with the help of EDA, we can also do that. For this, I'll just simply use this code. That is, let's go and write like this: category pd.dataframe value underscore counts, and then we are basically going to name it with respect to the count, right? So once I see the output over here, this will basically be my category. Okay, so just see the code, guys. I think you'll be able to understand. So family has 1972 counts, game, and top 10. If you really want to take, you can just use index, right? So what I'll do with respect to top 10, right, I'll try to create a bar chart. Okay, so for creating a bar chart, again, now see guys, you don't tell me to again write all the code line by line. I will just directly copy and paste it. So here I'm using a snh.bar plot, the category.index of 10. I want just a top 10 apps. So here I will just want top 10 apps. So definitely check it out. You'll be able to see it over here, right? And finally, you'll be able to see this. I've taken y is equal to count, data is equal to category of this, and pellet. I've used anything. You can use different pellets. There are, right? And then finally, you can see over here, this is how my bar chart looks like. And here also, family is given the best, like family has the maximum count. Then again, with respect to the insights, I've already written it over here. So over here, you can see family, game, tools, medical, business. So these are my top 10 famous app categories. So let me make this as a markdown quickly. Insights that I will probably get out of it is that family category has the most number of apps with 18% of app belonging to it, followed by games, and which has 11% of the apps. Least number of app belongs to the beauty category, and this all the information is there. And obviously you can actually check it out. Okay, now there are some more assignments that I really want to give you. Internal assignments. Okay, internal assignments. So first thing is that which category has largest number of installation. Okay, this is my first question to you all. Okay, which category has the largest installation? And then I will also keep some more question for you all, and here I will give the code, but I really want you all to try, okay, by using the things which are the top 5 most installed apps in each popular categories. I will give you the entire code over here, don't worry about it, but I am just going to ask you some 3 to 4 questions. Okay, so here is my third question. Okay, so consider this as an internal assignment. Write the code and probably post it in the discussion forum, but I will give you the question, I'll give you the answer after this one by one. Okay, and then you can probably have a look with respect to the answer whether it is matching or not. Okay, so these are the 3 main questions: which category has the largest number of installation, which are the top 5 most installed apps and all in each popular category, how many apps are there on the Google Play Store, which gets 5-star rating. So yes, do it, think over it, consider the data set, and then I will write the code in this, okay, for you all. I'll make it easy, but first of all, I want you all to try. Okay, so this is an internal assignment for you all. Please try to do it. Here I've already shown you, right, how to get the top 10 apps, how to probably get the top 10 app categories. Everything is there, right? Here also we saw with respect to that, which is the most popular app category based on the maximum percentage. Okay, so just try to do it. I will give the code anyhow, and you just try it out.